Hello everyone. So today we are starting with a new question, number of closed islands. So let's see what is the definition of closed islands. So here 1 is representing water and 0 is representing land. So this area marking this area is surrounded by water from all of the sides. You can see water is everywhere. And here also you can see water, and this is land. So in this example one, there are two islands which are properly surrounded by water, and an island is an area of land which is surrounded by water from all of its. And here what we mean from all of its side means, like this is a cell which we are representing for land. So its upper cell, its left cell, its lower cell, and its right cell should be of 1. 1 is representing water, so it should be of 1. It should carry value 1, and it should carry value 0. Carrying value 0. So any area of land whose left cell, upper cell, lower cell, and right cell is having values 1 is an island, is an independent island. So we have to find number of independent islands in the whole matrix. This is the whole matrix, and we have to find the number of islands. So let me clear how we are proceeding. Now I hope you all got the point of island in this question. So an island is a maximal 4 directionally connected groups of zeros, and a closed island is an island totally all left, top, right, bottom surrounded by ones. This is what I explained. And return the number of closed islands. We have to return number of. So as I explained, this is one island, closed island, and this is a closed island. We have to return the count of closed island. So here the closed island are only 2. Now you might be questioning that why this is not an island. This is land. You can see it is surrounded by water. 1 is there, but you can see here is none or null or whatever you can say. So it is not an island. It is also not an island because here it is surrounded by water, up and left side, but and bottom and right side there is none or null, whatever you can say. So it is also not an island. So only these areas satisfy all the conditions of these two. So we have to return the count of independent islands. So let's talk what we can do for this question. There are two approaches. One is DFS and other is BFS, and second one is BFS. So we can use any one from these two. So I am using DFS. So DFS is depth first search. I think you all are familiar with this algorithm. So what we can do for solving this question, it is a very standard graph problem. So we have to use an visit set, a set data structure, and when we are traversing our each element, so we have to check whether we had visited this index or not earlier. like when we are going through one, we have to do nothing. Whenever we will find 0, we have to apply DFS at that index. So like when we are applying DFS here, we can see that our rightmost is null, or whatever we can say, it is null or none or not existing or out of range. So basically it exceeds our range. We will set our constraints like r should be less than 0, or c should be less than 0, or r should not be greater than the length of rows. These are rows and these are columns. R represent the index of row and column. This is a 2D matrix, so we required 2 row and column index like 1 to 1 comma 2 or 2 comma 0 or 3 comma 4, like this. It is representing row comma column. So we have to check whether our R and C satisfy these constraints. In question part, I will clear more what constraints we are going to have in our question. So basically you have to just have an overview of how I will be proceeding further in later part of this video. So we have to apply DFS whenever we are finding a 0. We are finding a 0 here, so it will go to here, it will go here, and it will find all the zeros which are connected to this. So whenever we find a 0, we will mark it value in our visit set as visited. So what is the meaning of visited? That if one time we have visited this index, we don't have to traverse, or we don't have to use DFS again in this or in this or in this index. It will save our time and it will make our code optimize. Like we are visiting this 0, so by DFS we will be having this and again this. So not this is 1, so don't want to visit this. So you can see that we have visited this earlier, as we are traversing in a linear form, so we don't have to visit it again. So we can simply skip the visiting, as we will be searching every time, like if the array whichever, like the index at which we are standing at that time, it is in our visit set or not. So we will check our visit set every time, and searching in our set is having O1 time, so it won't increase the time complexity of our question. So after this, I can say you will be having a brief idea. So let's see how we are coding. So now let's see how we will be coding this question. Let's start coding it, and you will be clearing all the doubts while I am writing the code. I will be explaining what we are going to do here. So first of all, we are finding the rows and column length. So rows and columns equal length of our grid comma length of grid 0th element. It will be giving the rows and columns, and we are making a visit set, and now we will be writing our DFS function. So I am now leaving it empty, but on later part I will fill the details here. Now I will traverse the grid. For traversing, we will use 2 for loops for r in range rows and for C in range sum. Now if we will checking if our grid is not of 0, we will be checking always if not of grid if not of grid R and C, means we have to check every time that our grid is not of 0, means it should be 1. If it is 0, then we have to do DFS, otherwise we don't have to do DFS. So we are checking in this condition if not of grid, and we will also be checking if R and C not in our visit array. If they are not in our visit array, then we are only doing DFS. If it is in our visit array, then we will skip and we will proceed further in our matrix. And not in visit. And what not in visit? I have to write R comma C. R comma C not in visit. Then we have to do DFS. DFS of what? R comma C index. Here also I will pass R comma C, and we will be making a result variable here. First I will be assigning value 0, and whatever will be the return part, I will be adding it to here, result plus equals to DFS of R comma C, and at last I will be returning the result. So now let's fill our DFS function, whatever will be the condition. The first condition will be checking the boundary condition, should not go out of the boundary. So first it should be if R is less than 0 or C is less than 0 or R equal rows or C equal columns, then we have to return simply 0. If any condition fails or if any condition is failing, then we have to simply return 0. And if grid of R comma C and if grid of R comma C is equal to 1 or R comma C in visit, R comma C in visit, this is the only condition when we have to return 1. And when we are returning 1, this will add it to our result, and result is 0, and the DFS function will be returning 1, and after that we will be returning result. It will count the number of islands. But before that we have to add R comma C if the condition fails, and now we have to check all the sides of DFS of R comma C minus 1 and DFS of R comma C plus 1 and the DFS of R minus 1 comma C and the DFS of R plus 1 comma C, and I had to take minimum of all these, simply minimum of all these. minimum, had to use comma, and the minimum value of all these DFS will be returning to here, and then we will be adding one. So this is the whole idea. Now let's run this code. Int object has no attribute r comma c. Let's connect the here comma c. Time. So here you can see all it is passing. So this is the whole idea. So we are recursively calling DFS here, and we are returning the minimum value. If the minimum value is 0, then we will be returning 0, and if all the values are returning 1, then only we are returning 1, and at last we are adding the return value to our result value, and then we are returning our result. So I hope you got my point. Let's meet further in some new video. Thank you.